Start.
Welcome you all. In this video, we are going to see about one case study on the finite automata. Before going into the case study, first I will explain what is the finite automata. So, what is the automata means? Automata is an abstract model or abstract machine. As a end user, what is an abstract? So, abstraction is nothing but as a end user, we should not bother about the hidden hardware details. Suppose I want to, you have to on any switch means what is the abstract, what a end user you can do? You can do only the on and off. As an end user, that is an abstract. So that is like the automata is an abstract model that can accept that can read the input and produces an output. Whether that output is accepted means it produces a correct output. If it is not, there is any error in the input means that produces a reject output. So that is a model of an abstract machine, that is an automata. So that automata contains the two types of automata. One is the finite, non-deterministic finite automata. Other one is the deterministic finite automata. So what is the non-deterministic? That means the NFA means for a single input we have multiple outputs. That is a non-NFA. That's a non-deterministic finite automata. So DFA means for a single input that go to the another single statement. That's a finite single output that we produce. That is a DFA. So these are all the two categories of NFA and DFA. Now that automata, that finite automata can be designed, that could be designed in terms of states and the transition. So every automata or every day-to-day life we have our daily experiences are in terms of a state and transition. So what is the state means? Number currently one stage when you are moving into the another state, through by input only we can move to the another state. That is any triggering event in the outside event. Through the outside event only we go to the another state. For example, consider the daily life. Suppose you are in the home, you are going to reach a destination as you are going to the college. So what is the number of states in between home to college means? First home is one state. From home you are going to the bus stop. So from home to the bus stop, what is the input we are giving? So through the walking or bicycle, any transport we can go to the another state. So second stage is the bus stop. From the bus stop we have to go to the school or college. So what is the input? Through the traveling we are going to the, these are all the simple example of the state and transition. So every process in terms of state and transition. So you can tell about any example like that.
So real life example is like I will show you the diagram. For example, when you switch on a laptop that is shut off. The first state is shut off or it is off. This is the first stage. Now here the input is power button. Press the power button, the laptop is shut. Power button. Now the laptop gets switched off. So here now the state is laptop gets switched off. So here this is a good example for deterministic finite automata. Where I give an output based on the input based on the output. So I have to switch it on. If I press the start button, right? Now this is an input here. Now here there will be a lot of outputs like for going to Microsoft Word or PowerPoint or Flash or a lot of Microsoft applications like Microsoft Word, lot of Microsoft applications. Here this is an example of NFA, here input, but there are many outputs. So this is an example for NFA, non-deterministic finite automation. So this is a very good example for the automation process. And another example that I would like to give is the growth of a human. When a human is a baby, we give only food as an input, right? We don't give any teaching. So that is an example for FDA, finite deterministic automation. And after that, after the band becomes teenage, we give both input, mental thoughts like clarity, grounding, mental clarity, and also food. So here he has to give good human. So there are many outputs. So the growth of human and switching on to laptop and accessing both. These two are very good examples for the automation process in terms of scale and transition.
Now I will tell one scenario. Suppose you have a theater. That theater permits only the three categories of people. There is a size, child is followed by the mother can sit. That can be repeated in a many number of times. That is the second one. Third one, you can see child, mother and father. That is a child, mother and father. That can be repeated in a number of times. Can you draw the model for that restrictions?
So let me explain what you've asked for. The theatre scenario. So here let's consider the three inputs which you have given in a theatre scenario. There's mother, father and child.
No. Child, mother and father.
Now these are the inputs.
Okay.
Okay, these are the inputs and the conditions are three conditions. First condition is a child can be seated n number of times and a mother should always, so a child and mother should always be accompanied together. So that is a child followed by the mother, and that also can be n number of times. And there's a particular set where a child, a mother and a father, and it should be in this particular order where the child, mother, father should be seated. So this is only a one particular case. This could be n number of times, but let's just take it as a normal state. That's a singular state. Now let's take a Q naught state. Now with the input of a child, let's move to Q1 state. In the Q1 state, as you can say, it's an NFA where number of child can be repeated. So we can consider that as a self loop. So the child, next state is the second condition, that is a child and a mother. So here a mother is another input and Q2 is a state here. As you said, this can also be an n number of times, that is an NFL. So this can also be given the child and the mother in a loop. Next is Q3. So moving to Q3 we need father. So this concludes all the three inputs. So we can conclude this as a final state where it all satisfies all three conditions and the system accepts this three as an input.
Fine. Now I will tell one question. Suppose there is a combination of child and mother. We have child and mother. So what is the state transition?
For this state transition, so
You can tell only the states. What are the states?
the first state is consider the child, a Q naught state. So the input is a child, again a child, Q1. So the input, as you said, child
Again,
and a mother.
again child.
Ah.
Again it goes to the Q1.
Q1 set. No, this is for the mother. And suppose we have to consider a condition of repetition of children.
Child and mother. So one is the statement. Q0
Then again Q1.